Hello, my name is Dino Tinitigan. That's my partners Angel and Prut. And our project is about the S.M.P, which is the Smart Mobile Platform. And this is the black diagram of our project. Basically, the philosophy is we're going to divide the projects into modules. And we're going to have a master module. And all the other modules are going to connect to the master module to send the data to the master module. The master module connects it to an embedded system. And it also connects to the motor controller or driver, which controls the motors. The modules. The control module. Basically, the control modules send the control data to the master module, which is basically what controls the motors forward, left, right, whatever, backward. Sensor modules sends the sensor readings to the master module. And then we have the navigation module, which has the GPS and a compass. And master module, like I said before, just accepts data coming in. And we also have custom modules, which can be added or removed depending on the application. And the modules, once again, we have it that the philosophy, so our design is expandability and has some versatility. And we're using divide and conquer philosophy, one module per design. And it also allows us to monitor the status of each module and if it's working or not. If it's not working, remove it, replace it with another module. So what are we actually doing? Basically, our project is the S.M.P idea implemented on an electric wheelchair. And a part of the project is the alternative control system, the collisions avoidance system, vital signs monitoring system, and a GPS navigation system. And of course, a web interface for monitoring the data. Okay, I'm going to talk about the alternative control system. Basically, the alternative control system is just, sends the control to the master module, like I said before. But it's designed so that anybody can control the wheelchair. Like, for example, the head control. For example, if the person is quadriplegic, he can control his arms or legs. Then we have the head controls. We could do a tilt up for a certain command, tilt down for a certain command, look right, look left, or tilt right, tilt left. And next thing. Auto control systems. Since we did the modular design, we could just plug and play a voice command system, a remote control system, or maybe installed control. That's again part of the control module. That's just different types of controls, the pictures over there. Next is the collisions avoidance system. Basically what it is it just uses sensors to prevent collisions. So whenever an object is detected, we could tell the motor to stop going that way. Also prevents move command when there's already something in there. And the number one reason for this is safety. Here's a picture of it. Basically what we have here is some sensor. If there's no object detected. If there's an object detected, and so on. Now the embedded system. We have the embedded system so we could provide a GUI or a graphical user interface to the user. It also provides us with internet connectivity so we could send our data to a database. And if we want to add other tasks to it, like video processing, we can have the more powerful embedded processor take care of that. Now for the optional systems. There are a bunch of optional systems that we can implement, like the vital signs monitoring system that I talked about earlier. Basically, it's just an ECG circuit that measures the heart rate and the signal. And a GPS navigation system, which is for navigation. Again, it's part of the custom modules. And this is the web interface for our project. Basically, we have a camera, so we could monitor the person in the wheelchair if we need to. And we have a map, so we could, which is Google Maps, so we could track the wheelchair if it is needed, and an instant messaging box. That way we can talk to the user by IM. And then here's the, if you need to monitor the person or the patient, you can monitor the heart rate and some alerts. If there's something happened to him, his heart stopped, then we can issue an alert right there, and we know that something wrong happened. So what's our motivation? Our main motivation for this is to help people and to design a mobility system to suit the needs of everyone, depending on their disability or their needs. Now, what are the other applications of the S.M.P idea? Besides the wheelchair, we could pretty much implement the idea into anything that moves, basically anything with an electric motor. Like we can implement on a surveillance or security platform, which is the S.M.P's controlled remotely. It's going to have video feed, alarm system, or maybe even something, an non-lethal weapon system. Or another thing, it can be a research platform. Basically, since we have the modules, and we could release all the data on how to create the modules, and anybody can create their own control module, create their own sensor module. Let's say somebody wants to make a controller for the leg. Then they could just, as long as they follow our protocol, they can do that. This is our project website and our names. Basically, we have a website so the people can track the progress of our project. Go to project status. Project status. Here you could see what's our progress. What part of the thing is still in development and which part has been completed. Project info just gives us basic info about the project, and so on. I mean, the website's still in development, so it's kind of empty right now. And about us, if anybody needs to contact us, it's over there. So yeah, that's it. Questions?